Hello everyone, welcome back to my YouTube channel. Myself Rakshit, studying in Sri Venkateshwara College of Engineering in the Department of Computer Science Engineering and Artificial Intelligence. Today I am going to explain you the text search using the finite automata. In this presentation, we will explore the applications of finite automata in the text search. We will also discuss the fundamental concept of NFA and DFA and their roles in the efficient text searching. The NFA means non-deterministic finite automata and DFA stands for deterministic finite automata. Let's start. Introduction to finite automata. Finite, finite state machine. A finite automata is a mathematical module of computation that represents the machine in with a finite number of states. It can also transmit between their states based on their input symbols. Next is transaction. Transition state transition between the state are defined by a set of rules called as transition function. Each transition represents a challenge in the state of machine in response to an input symbols. This is the introduction to finite automata. Next one is non-deterministic finite automata, means NFE. Multiple transitions. Multiple transition. In NFA can have multiple transition from a state for from the same input. This non-deterministic allows for flexible in pattern matching. Next one is epsilon transition. NFA can also have a epsilon transition, which are transitions that occurs without reading any input symbols that allows for more complex pattern recognitions. Next one is the acceptancy. In NFA, acceptancy is accepting if there exists at least one path that the math machine that leads to the accepting state. This is all about the non-deterministic automata. Next, we move to the conversions of NFA to DFA. First step is the power set conversions. This method creates a DFA from an NFA by formatting a state from the power set of the NFA states. Second step is deterministic transitions. Each each state in the NFA represents a set of NFA states. The transitions are defined based on the possible transition from NFA state in the set. Next step is the accepting state. A DFA state is an accepting state if any of the NFA state is its set in an accepting state. These are the conversions of NFA to DFA. Next one is the deterministic at finite automata. It's DFA. In single transitions, DFA has exactly one transmission from each state for every input symbols ensures a deterministic behaviors. This is a single transition. Next one, efficient search. In this deterministic finite automata, the determination makes them efficient for text search because they can process the input symbols one by one follows in a single path through the machines. This is this is called as efficient search. Next one is a simple implementation. DFA are easy to implement than NFA, and they can recognize less complex logics and data structures. When we compare with NFA, DFA is easy to implement because it's less complex logics and less data structures, and it's easy to implement. Next, we move on to the applications of text search using NFA and DFA. Some of the applications are keyword search, pattern recognition, code analysis. Keyword search. NFA and DFA can be used to search the specific keyword in a larger text document. This is one of the applications of text search. Next one, we move to the pattern recognition. This can be used to detect and recognize complex patterns in text, such as email addresses or phone numbers. This is used to recognize the pattern recognition. Next one is code analysis. Using in code editors and some compilers for syntax highlighting and error detections. These are some applications of text search. using NFA and DFA. Next, we will move on to the advantages of NFA and DFA. Advantages of NFA: more efficient, expensive, and can represent complex pattern using epsilon transactions. This can be more compact than DFA for certain patterns. When we compare with the DFA, it is more compact than the DFA. We'll move on to the DFA advantage. Deterministic behavior efficiency for text sets, similar implementation. It can be more efficient for same applications, particularly those with a large input sets. These are some advantages of NFA and DFA. Next one is conclusion and the future directions. The powerful tool. NFA and DFA provides a powerful tool for text search and pattern recognition and code analysis. This is going to be one of the powerful tool for the text search, pattern recognition, and code analysis. And next is the efficiency versus complexity. Choosing between NFA and DFA depends on the complexity of the pattern and need for the efficiency in the application. We need to choose the NFA or DFA depends on the complexity of your application and efficiency or pattern recognition of your uh, application. We need to select the this NFA or DFA. Next one is the advancement. The field of automata theory continues to advise with new algorithms and techniques being developed for more efficient and robust text search solutions. This is some advancements of NFA and DFA in the field of theory of computation. Thank you, one and all. Please subscribe the channel, like the video. Thank you.